Okay, in this video I'm going to show you how to multiply radical expressions where the indices are different, right? So here I have like a cube root, for example, of x squared times the square root of x to the fourth. And I'm going to show you a method called the Crisscross Method. I've showed you some other methods before in previous videos where we did fractional exponents or that sort of thing, but with these guys, there's actually a really cool technique that we can use that really shortens things up for you, right? So I'm just going to use these two examples. Now, I'm going to show you a simple example where there's only one radicand, right, under each. And I'm going to show you a more involved one over here so you get the idea of how nuanced this is. All right, so let's get started. So what do I have here? Like I said, I've got the cube root of x squared times the square root of x to the fourth. Now, in this method, what you do is, first of all, look at the indices and you multiply them. So cube root and square root. So I'm going to multiply 3 times 2, and I'm going to get the 6th root. Okay? Now, let me show you how this kind of looks. It's almost like doing a little triangle, right? So I've got a 3 and a 2 there. Just multiply these two guys first. Okay, now the second thing I'm going to do is I'm going to take the index of, let's say, the far left radical, right? So the 3, and I'm going to multiply it by the exponent of the radicand in the opposite radical. Now, again, that's a lot of words. Let me show you what that looks like. I'm going to take the 3 and I'm going to multiply the 4. All right? So that's going to give me x to the 12th. All right? I'm going to do the same thing with the opposite ones. I'm going to take this 2 here, this index of 2. I'm going to multiply it by this exponent here. So it kind of looks like this little triangle, doesn't it? And that's going to end up with x to the 4th. Okay? Now you may have noticed that the x to the 4th and the x to the 12th, you can just add those, because since the bases are the same, you can just add the exponents, and that gives me the 6th root of x to the 16th. Now here I can do any number of methods to simplify this, right? I know that, for example, if I can match, I can go the 6th root of x to the 6th, I can do another x to the 6th, and another x to the 4th. Why did I do that? Because 6 plus 6 plus 4 is 16. The reason I took these guys out is because when these match, you just take the exponent, or you just take the x and you just put it outside, right? Because it's a whole number. This one becomes a whole number. It goes on the outside. This one stays underneath. And I can rewrite this finally as x squared times the 6th root of x to the 4th. I can also continue to simplify this, right? I know that 6 over 4 is another way of saying 3 over 2. So I'm going to say x squared cube root x to the 2nd, right? And that would be the simplified version using this little crisscross method. Simplified version, it's not really all that simple, but you can see it's kind of involved, isn't it? But you do come up with a rather quick way of multiplying these two radicals. Now, let me show you this one over here. Now, the reason why this one's a little bit more complicated is because I'm going to have to take the prime factors of the 9 and the 27 first before I can do anything. So let's do that. I know that 9 is really just 3 squared, isn't it? I still have an m cubed. I still have an n squared. 27 is really just saying 3 cubed, isn't it? And then an m to the first and n to the first. I'm putting them in there deliberately because I want to be able to multiply them by the index. So again, just like before, go ahead and take the index, multiply those first, and I'm going to get the 6th root, right, of whatever comes underneath. I'm going to do 3 times 3 cubed, which is 3 to the 9th, 3 times m to the 1st, which is m to the 3rd, and then 3 times n to the 1st, which is n to the 3rd. Now do the opposite. It's going to be 2 times 3 squared, 3 to the 4th, 2 times m to the 3rd, which is m to the 6th, and then 2 times n squared, or n to the 4th. Now it becomes this simpler problem. Remember, where you can just add the exponents when the indexes are the same, or indices, plural, are the same. So 6th root of 3 and 3, so 9 and 4 becomes 13. M cubed, m to the 6th becomes m to the 9th. N cubed, n 4th is n to the 7th. Now I'm going to do something slightly different that I did over here, because I think I might have confused you a little bit, but let me just go ahead and show you. If I change these to fractional exponents, remember it's exponent over index. It's exponent over index. It's exponent over index. Whole numbers go outside, the fractions less than 1 go inside. So I see there's a 3 squared in here, because it's really just 3 and 2 and 1/6, right? 13/6 is 2 and 1/6. M is 1 and 3/6. 9/6 rather is 1 and 3/6. And the n is just 1 and 1/6. Whole numbers go outside. So 3 squared, m to the 1st, n to the 1st, and then the index is 6, so those go all back under, and I have 1, 3 to the 1st, I've got m to the 3rd, and I've got n to the 1st, and that would be your answer. Okay? So again, the crisscross method is kind of interesting. Multiply the index first, then you take the opposite index and multiply it by the exponent in the opposite radical. Do the same thing here, and then simplify it using your math knowledge with exponents. Okay? I hope that was helpful.